We continue our discussion of pointers for my data abstraction class with a video talking about the actual syntax of pointers. So we saw previously that we can use the @ sign or the ampersand to stand for address of, and this takes the address of a variable and gives us its memory address and location. Here, the star is actually part of the type information, and you're allowed to put as many of these as you want. So a declaration like that is just an integer. This is a pointer to an integer. This is a pointer to a pointer to an integer. This is a pointer to a pointer to a pointer to an integer. And there really isn't a limitation on how many of those you can put in place. There are limits to how many make sense, but it's actually very common to have pointers to pointers. In fact, it's so common, there's a term for it. It's called a handle. So what about going the other way? So we saw that this ampersand allows you to get the address of something in memory. What if you have the address of something in memory? And I actually kind of demonstrated this in the last video when I was trying to figure out what was going on, when I had taken the address of temp, when I actually just wanted to print out temp itself. And the operator that goes in the opposite direction, so once again, this gives us the address of something. To follow that address, to go to the value, is actually the star. So star B, in this case, would be to follow the address that B points to and give you back the value that it points to, which in this case, because B is the address of A, it would follow that pointer, go to A, and then give you back the value. It can also be used to assign to A. In fact, so let's go ahead and let's look at that. So I'm going to get rid of a number of these things that we aren't using in here. We print out B. Let's go ahead and let's print out A. And I'm going to get rid of these calls down here because we don't really need them. Between these two prints to A, I'm actually going to say star B equals 99. Okay. And while we're at it, let's go ahead and, of course, star B is A, because A was set to be a pointer that points to A. So this and this should print out the same thing. Here they should print out 42. The thing to note here is that because star B is pointing to A, star B, when you dereference the B, is actually giving you back A. And so when we use it in an assignment, we're actually making an assignment to A. This is the same as saying A equals 99. And so after we've done that, the print statements, both for A and for star B, are 99. Okay, so a lot of times I like to think, and I just have this tendency, I think in types. And basically putting an ampersand in front of something gives you an additional star on the type. So the type of ampersand A, where A is an int, this has the type int star. Okay. Ampersand B gives back the type int star star. Because B itself is an int star, the ampersand adds an extra star here, and so ampersand B would give us a handle to an int. The star operator goes the opposite direction. It actually removes a star from the type. So whereas B is an int star, star B is just a plain old int. And if we had a variable whose type was int star star, putting a star in front of it would take it down to just an int star. Okay, so the ampersand, as far as the type goes, adds a level of dereference. It adds a pointer in there. Having a star takes away a pointer in there. Turns out that the star isn't the only way to dereference things. Okay? There are two other operators that will work, or that are significant for this. One of which is the brackets. You'll note that that printed out 99. So it appears that b sub 0, adding a subscript and a 0, is the same as following it. And indeed it is, because this right here is a shorthand syntax. When I say, so b, let's just say sub I in general, is equivalent to star of b plus I. What this does is it takes the address b and it offsets it I elements. Okay? I elements that are of the size of whatever b points to. Okay, so if b points to ints, this will move it forward the appropriate number of ints. If b pointed to chars, it would move it forward by the appropriate number of chars, and it dereferences it. Okay? So these two things are equivalent. Typically, if you're using something as an array, this is the syntax you will use. There had been a time when this wound up being faster. You could do things faster with pointer arithmetic and whatnot. However, for the most part, compilers now will optimize the code so that you can use an array notation, and it should run at the same speed as if you actually play around with pointers. There is another piece of syntax that is used that winds up basically getting translated into something that has a star inside of it. And this is significant when we have structs and classes. So let's go ahead, and let's declare a struct point, which has a double x and a double y inside of it, and point p. Something to note, variable declarations. This is the variable declarations. I would argue in all modern languages you should follow the same rules. You should declare your variables as close as possible to the point of usage, and if it is an option, declare them at the point where you know the value that you want to stick into them. Because this is a struct with two fields, this should work to initialize it. Let's make sure I'm typing everything in happily. Okay. So this will, x will have the value of 1 and y will have the value of 5. And now I want to make a point star, or a pointer to a point. So I'll call it pp. And pp is going to be equal to the address of that point that I just created. If I wanted to print the x field of p normally, I would do it like that. What if I wanted to go through the pointer though? Well, this doesn't work. Turns out that the pointer doesn't have a dot on it, and indeed if we try to compile this, you will see that there is no, it's a request for member x in the pointer, and that's not correct. This is a wonderful error message because it even tells you that you might want to use an arrow instead. So the long way of writing this out would be to take us to use the star, but it turns out that the dot binds higher than the star, so we would have to put this inside of parentheses. So this will work. Okay, you can do this to access elements of something that you have a pointer to. However, because this is something that is done so commonly, and because having to put all those extra parentheses around the stars is such a pain, there is a shorthand syntax which uses an arrow. So turns out that in general, a arrow b is equivalent to star a dot b. And when we run this, we get two values of 1 here because that was the value that we put inside of x. So that gives you a basic introduction. We had already seen the ampersand. We've now used the star for dereferencing. You can use it both to retrieve the value, because the thing that you get back is actually a variable that exists inside of memory. You can assign into it. And we also saw how bracket notation is equivalent to a dereference with adding to the pointer. We also saw how the arrow notation is equivalent to a dereference and pulling out a member. We'll come back next video and we will look at the how arrays fit into this, and in particular dynamically allocated arrays.